So guys, we're finally back with the next episode of the series after 2 months. I've been quite busy lately and never really had the time to upload the next part. Oh, and did you notice? I now have 150 subscribers on this channel, which is just absolutely amazing. From this series itself, I've gained 49 subscribers. So I just want to say a massive thank you to you guys. Alright, so guys, basically in part 8, we're basically going to improve the game performance. So the way we're going to do that in this video is removing the unwanted faces. So for example, let's say in this diagram over here, you can see there are 2 cubes. Now, these 2 cubes have one face each that can be seen, that cannot be seen, and you can see it's like hiding over there. And basically, we want to eliminate these faces and make them not visible to the game, okay? Because these faces are just useless because I can't even see it in the game, so we might as well just remove them. And this improves game quality and the performance of the game and increases the FPS and yeah, many more things. So firstly, I just want to add a FPS indicator. So this is our world, okay? As it was like 2 months ago or something. And yeah. See, nothing has changed. I haven't done anything, but basically what I want to do now is just add a small box over here that shows the FPS of the game, and it can also show the ping or other things. Okay, so the way we're going to do that is we're going to use this built-in THREE.js module. We actually have to download it, so technically it's not built in. So all you have to type in is THREE.js stats. And I'm going to put a link to this in the description, and I'm also going to add this to the GitHub repository, my GitHub repository of this project. So yeah, it's going to be updated with a new file. So just click this link and click on build, and then just click either the first one or the second one. Okay, minified, I might have already said this in the series, maybe not, but minified just minifies the code into like one line, and it's kind of more efficient, you could say. So yeah, you can download any of them, but I would recommend downloading stats.js because it's more readable, because like, you can read the code. So yeah, so just click on that, click raw, and then save as anywhere you want. Okay, and you don't have to give an extension .js because it's already indicating that it's JavaScript. So the computer is gonna put a .js extension at the end. So I'm gonna put this in THREE.js work, save. Now I can cross this out. So this is my THREE.js work folder. Your Minecraft folder for this project will be different. Like for example over here, this is my Minecraft folder kind of. I just named it THREE.js work since the start of the series. And yeah, there are like other programs here. But just imagine that none of them are here, and just the Minecraft and stats.js and noise. Where's noise? Yeah, Perlin.js and THREE.js are there. Okay, so basically stats.js, it should be inside the same directory as your 3D Minecraft.html file, and yeah, you're ready to go. So all you have to do is cross this out, go to Sublime Text, and code. Alright, so the first thing you want to do is import this stats.js library. So stats.js, and there are no slashes, so like desktop / blah blah, because it's in the same directory. Okay, the next thing you want to do is type in var stats. This is declaring a new instance of a stats object. So stats. Yep, so var stats is equal to a new stats, and just saying stats stands for statistics, and yeah, stats.show panel 0. Okay, and now I'll just put some comments to what this means. So 0 means FPS, 1 means ms, 2 means MB, and 3 plus means custom. So the one that we want to show is FPS. You can also show these two things or like your own custom one. And then the next thing that you want to do is you want to append this to the body. So document the body dot append child stats dot dom, and dom stands for document object model. And now you want to do function. Oh god, what just happened? Okay. Now you just want to do function animate. You can call this function whatever you want, but I suggest calling it animate. And then you can say stats.begin and then stats.end. I'm just saying the monitored code goes between these guys, so monitored code goes between these call functions. Okay, so that's that. And then the last thing we want to do is request animation frame and then animate. Okay, so now if we go over here, we should see FPS. Oh, it's actually not showing the FPS. Oh yeah, sorry, I forgot to do this, obviously. So request animation frame, you also want to put that over here. And yeah, you're ready to go. So yeah, there you go. So 9 FPS, 37 FPS, 39. So if you play Minecraft, this is decent. So 40, yeah. And oh, by the way, over here that shows the minimum FPS of the whole session. So that's 9 FPS to 53 FPS. That's the minimum and the maximum. So if I refresh, it started from 14, you could see, and then right now it's on 52. If I look down, it just goes to like 60 FPS because it's not rendering so many vertexes. So yeah, so basically our objective is to eliminate the faces. So let me just show you. Oh, what just happened? Okay, whatever. So these two blocks over here, they have a face. So this block has a face at the right and this block has a face on the left. Our objective is to eliminate those two faces because, you know, I mean, I can't even see them. So what's the point of them even existing, right? So that's what we're going to do, and hopefully that's going to increase the FPS. And just saying, in later videos we might improve game performance by different methods. So like we might merge the geometry together, and yeah. So in this video we're just going to remove the faces. Yeah, so let's start by doing that. So just go down to your function block constructor thingy, and you have to make sure you have to remember this part because we're going to use that kind of. So yeah, the first thing we want to do is make an array of objects. So you just want to copy this, or just like, you know, just write it up. Basically what this does is it puts the faces, because we're going to be using this afterwards. So it says that if there is a block in so like let's say I'm talking about one specific block. Basically what this does is it says left means there's a block in the left. Okay, right means there's a block in the right of the block, and bottom means that there's a block below the block. Top means there's a block above the block, and so on. Okay, and -5, 5, and -5, 5, and -5, and 5. That basically means -5 is left, 5 is right, -5 is bottom, and so on. Okay, and this x, y, z, so that's why that works. And the reason why it's -5 and not like -1 or -2 is because our block size is 5 pixels or 5 units. Okay, so yeah. After this, we want to make two functions inside the block function. So the first one is going to be a this.getVoxel function, and is equal to function. Alright guys, so this function over here called this.getVoxel, it basically takes in 3 arguments, x, y, and z, and it basically says if there is a block in that position. Okay, So if there's a block, and then it goes through each of the blocks in the chunks array, in the 2D chunks array, and it checks if the positions of the block match the positions of the argument, and if it does, then return true, there is a block in that position, else return false. And now we just have to create an array for this directions. There's just an array that it's going to have right, left, and so on for this specific for the block. So it's like a property of the block that basically says which direction is there another block. So let's say I'm a block, okay, and over here, let's say I'm a block over here. If there's a block over here, then this directions would have left in it, okay, because there's a neighboring block in the left. So it would go like left, top. That means that there's a block in the left of this block and in the top of this block. Yeah, so after this, what you want to do is create the function that adjusts the faces. So this dot adjust face is equal to a function that is so this dot adjust faces function is going to be this over here, and what this does is it goes through each of the directions of the face array. Okay, so remember over here we created a faces array with objects. Okay, so it goes through each of these objects and goes through each of the elements of the object, and it basically does const neighbor is equal to this dot get voxel. Okay, so const neighbor is equal to this dot get voxel, blah blah blah, and so basically it puts in these coordinates in the get voxel function, and it checks if there's a voxel there, if there's a neighboring block there. So basically what this means is direction 0. Let's say the first iteration is this element over here. Direction 0 will be -5. So this dot x plus -5, and that will mean left. Okay, and everything else is 0. This dot y plus 0, this dot z plus 0. So if you just go -5 and nothing else, that's just left. If you just go -5 on the x-axis, that's left. Okay, so what this means is that left of this block, is there a neighbor in the left of this block? Is there a neighbor in the... Oh, by the way, this can also mean right, okay, because it can also mean that over there. It can mean, yeah. So I hope you get the concept over there. It's quite simple to understand. And then what this does is it returns a true or false statement, and a true or false boolean. If it's true, it does this, and if it's false, it does nothing. And okay, so it puts these coordinates into the get voxel function, and it checks if there's a voxel in the neighboring place of the block. Okay, so if it's true, if neighbor is equal to true, you don't really have to put that, but you can if you want. It goes through the third element. So this is the third element: left, right, bottom, top, back, and front. And then it says if it's right, if it's left, if it's bottom, if it's if it's bottom, if it's top, if it's back, or if it's front, it puts it into the directions array. Okay, so it depends what this block of code over here does, including this. Basically, it says which directions, if any, are the neighboring blocks of this certain block. Okay, and now after that we have to call this function. So we have to call adjust faces, this dot adjust faces. And now the next step is, instead of this, we have to kind of change that. So we have to delete this actually and just put that over there. And now we have to make a new array. Okay, so like over here, this material array is for like each side, right? So like this is for one side, this is the top side, I think. Sorry, that's the right side, that's the left one, that's the top, that's the back, that's the front. Sorry, that's the bottom, that's the front, that's the back. Okay, we basically have to do the same thing, but put if statements. Okay, so so basically what we want to do, so everything was the same apart from this, apart from the the material part of the mesh. Okay, so basically what this does, this is right, this is the left side, this is the top side of thing, this is the bottom side, and this is the front, and this is the back. And is this right though? Yeah, I think it is. Yeah, whatever. Yeah, it doesn't really matter, like you don't really need this, but you actually do, but yeah, whatever. So yeah, it says it over here, right, left, top, bottom, front, back. And yeah, what this means is if the directions of this block, this array, if it includes right, then, so this is true and that's false. Basically, there's a condition statement that says if this statement is true, then do this. But if it's false, then do this. Okay? And if you want, I can write it up over here. So condition, question mark, true, false. Okay? So if this is true, then do something. But if it's false, then do something over here. Okay? So if it's true, if there is a neighboring block in the right of this block, then make that face null. So there shouldn't be any faces, right? There shouldn't be any face in the right side of the block. But if there aren't any, so if it's false, if this condition is false, then put a face. And the same goes with all the other ones. Okay? And with that, I think we're done. So let's just see. FPS has increased. Has it increased? Further to check if it works. So let me just refresh. That block over there, that's the first block in the world. So 0, 0. Dot directions. So it detected right and front of it. That's correct. That's front and the other side is back. Chunks 0, 0 dot mesh dot material. And yeah, there you go. That's the first one. That's right. And that's the fourth one is front. So there are actually no faces in the right of that block and the front. So perfect. That's actually really good. Okay, and you can see the FPS over there. It just went to 60. Yeah, it kind of fluctuates, but now 58, 60, and so on. And yeah, the FPS is actually much better now. Obviously, it's still laggy, so we still have to make some other improvements. Maybe we can merge the geometry or something. So if you guys have any ideas on how to do that, please leave it in the comments below. And the last thing that I want to add in this program is, firstly, I want to increase the render distance. See what that does. Let's say 5. Ooh, okay. It is lagging, kind of. It is. It's definitely much better than last time, but it's still lagging, as you can see. When it sees like more geometry, then it lags. So that's the problem. And yeah, it does lag. And we also have to fix that. You see, I just went through the world. We also have to fix that, the collision detection system, but that shouldn't be too hard. Yeah. So yeah, just like that. Okay. So we have to fix that afterwards. Oh, that's a mount. This is a mountainy biome. Yeah. So we have to make this game less laggy. That's the point of the next couple of videos. If you want more higher render distance, please, if you could help me out. Search up how to do this. That would be quite nice. I know some of you guys have already tried to help me, like Gabriel, Coco, and some other people. So thanks to you guys. And yeah, the last thing that I want to do is just add a fog to this game. So you can just go over here and just do scene dot. You can just do scene.fog is equal to new 3.fog blah blah. That's the color. That's the color of the fog, and that's the near, and that's the far. So this will be a black fog. As you can see, it looks pretty cool, but I think we should do this like at nighttime when we make nighttime into our game, or caves. This would be pretty cool for caves or something. You can also make this white. So If it's white, it looks like more like realistic fog. You can see it's white fog. Looks pretty good. But I personally like black more, so yeah. So yeah, with that, we're actually done with this video. We actually improved the game performance, as you can see in the split screen over here. At the start and in the last video's program, it actually performed not so good. I mean, even this is not performing too good, but it's better. Okay, so it's an improvement to the game. That's good. We can always make some more improvements through the way. And yeah, if you have any more questions or feedback or anything like that, please leave it in the comments below, and see you guys next time.